Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Solid Code, a holistic approach to code quality. Our guest speaker today is Mr. Sachin Bajpai, Specialist Platform.net at Sapient Global Markets. Sachin has over 9 years of experience in the IT industry working with Sapient. He has been leading several critical projects from the technology front at Sapient Global Markets in the trading and risk management domain. His interest areas include developing high-performance applications and exploring techniques and frameworks for maintaining code quality. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Sachin.
Thank you very much, Mohini, for arranging this session, and in general, thanks TechGig for such a wonderful platform. Let me just quickly start. I hope everyone is able to see the screen. Quick check. So, Moni, is it possible that you can confirm that you can see my screen? Yeah, you can see the screen?
Yeah, I can.
Okay, all right. Thank you very much. Folks, a very good afternoon to people in India, and also greetings to people who have joined from other geographies. Today we will be going to talk about a very important aspect of software, which is solid code or code which actually can live through a duration. And we'll be talking this about in terms of saying that this is a holistic approach in terms of code quality. I see a large number of people who have joined in, and then it already shows that there is a problem which people have identified, and this is I see this as the first commitment in terms of resolving that. So I'll try and in this session to talk about code quality, and also talk about that what exactly a framework can be developed or understood which actually binds you in order to deliver better quality code rather than exploring different options. In terms of agenda, I will be talking about 3 different things here. First, I will be trying to discuss about overall quality mindset, and also to understand the different perspectives of quality in a different stakeholder environment. Then I will be talking about a quality coding framework which we have developed within Sapient, and then talk about that what are the different elements of that, and then how it can help you to basically create an environment which is conducive to producing quality code. And the third and the fourth most important thing here would be that how do you socialize in your organization or in your team, and how to make that environment conducive for it. And towards the very end, I will be talking about the summary and picking up questions. Okay, so the first section, let's start discussing about the overview of this. So here, I will try to understand. I will try to make you understand that what exactly is quality mindset, and what are the different challenges in maintaining it. If you see this screen, you see there is a girl who is smelling a flower, or she's seeing a flower, and for her, this is a quality flower. Similarly, if you see the next image, which is you see measurement tape, and this is a product-based definition of quality. So I will try to throw different images here, and all of these actually are quality in a different perspective. For example, one way of defining quality is transcendent quality, which says that I can feel quality, but I cannot measure it, or I cannot define it. That's what this girl is facing. Similarly, for a user-based quality definition could be that a certain user only likes one different thing. For example, if you see in this image, there are 2 shoes. One is a shoe for a girl, and one is a shoe for a boy. So a girl will only like a girl shoe. So that is her preference, and that is called a user-based quality. So overall, if you see here, there are different perspectives of code quality and internet quality in general, and we have to appreciate that different stakeholders will have different vision of that. In this slide, I actually want to all of you to basically look and understand, think about. Let's assume that you take an example that think about any most respected, for example, most respected brand for a mobile company, and then also you think about a most profitable brand for a mobile company. Similarly, you think about the most sustainable brand for a mobile company. If you see in all these things, I assume that more often than not, people will actually think about a product like Apple. So what exactly is there in Apple which makes it very respected, profitable, and sustainable? The thing here is that they have maintained quality to the hilt. They have tried to have that mindset there so that it actually meets the customer requirements. I just want to also highlight that if you just switch that, and then if you think about in terms of creating an example, for example, then all these three things will definitely hold true for someone like Mr. Tendulkar, who actually is respected, profitable, sustainable. But then you have to think about that what these things have in common. Why are they so sustainable? And then why they are so they can exist for such a long time. The main thing which we have to understand here is that they are following a certain quality standards, and this could be even true for you as a developer, as a potential person who actually develops applications, that you can be a most respected developer, you can be most profitable and sustainable developer, but then do not. So you have to think about that quality mindset. So in these two slides, we actually talked about, until then we have talked about what exactly is code quality, what exactly is quality, what are the different perspectives, then why is quality important. But let's now get our focus back to the software world, wherein we have to understand that what are the different perspectives of code quality or software quality. I have listed here some 6 or 7 different attributes of a good code. So it has to be an efficient code, it has to be a stable code, a maintainable code, extensible, testable, and readability. So these are, and you can go and check. So I have provided a link here which says that there is a standard for code quality attributes. It's called 9126. You go and check there. So this whole definition of code quality and then what software quality is all about. But how do we deal about it? How do we actually think from here on to the ground level, where we say that when we write classes and we write methods, that how do we keep all these things in mind? So the next slides, or the whole framework which we'll be talking about, it will be about how exactly we can do that. In this slide, I actually want to highlight one thing that, and most of the developers or the project managers who are already attending this, they would agree with me that if quality is not managed, then something goes wrong, and then your code actually starts having a delta from the state which it should be. And this term is called technical debt, which actually comes while you're trying to do things which are quick and dirty, and which results into technical debt. More often than not, technical debt eventually leads to the software being scrapped and eventually dying. And this is the biggest problem which we have to sort out, and that's how these frameworks can be useful. Challenges. So we talked about what is a good code, what exactly is a technical debt, what are the challenges. One challenge, for example, which everyone will agree, is that delivery pressures. We have signed up for something, the estimation is not up to mark. Developers feel the pressure that they have to deliver functionality within a certain time frame. So that is one different way. The other thing is that maybe few developers who have a good quality mindset, but the others don't have. The whole environment is not conducive, so missing of quality mindset. Then there is also that we have issues in terms of tools and processes. We do not have this proper skill set in that. Sometimes the standard guidance is missing. So all these things are the different issues while we have to deal with the with writing good and solid code. Okay, we have talked about different perspectives of code quality. What is a good software? What are the different challenges in that? Let's now try to think about a scenario where we are able to have a solution mode for this. In this thing, I will try to basically introduce you to something an example, and then I'll try to relate that example with this code quality framework which we have developed. So in this code quality framework, I'll be talking about 5 different elements, which is it's like quality coding, having a continuous delivery framework, following test-driven development or TDD, as we say, pair programming, and having good code coverage. And then I would like to everyone to basically think about a scenario that assume that there is a child, maybe his name is Sanjay, and he wants to learn cricket, and he tries to idolize someone like Virat Kohli, who is a good cricketer, and then he wants to himself to become a good cricketer. The first thing he has to do is that he has to enroll himself to a sporting academy, and then he has to start learning that, right? And the sports academy will ask him to buy equipment to start playing the sport. So he has to go and buy something, bat, glove, or things like that. The first thing in order to do anything would be to buy the equipment or the tools that can help you. Similarly, in our example, we call that aspect as quality coding. So and then I'll cover all the 4 different elements while we come to the point. So let's see that these 5 elements can actually be divided into either it's a mindset thing, as in which is in terms of understanding or in terms of living code quality, and a few other things like quality coding, test coverage, and continuous delivery framework. These are the toolset part of it. And we understand we have to be good in both of these things. Unless and until we do not have a good mindset, it will not work out. If we do not have toolset, it will not work out. So as I discussed about the equivalent part of the quality coding part, let's try and see the first aspect of it. Yeah, quality coding. So as I said that we have to think about the different equipments or tool set for doing good coding. The first tool which you should be having is a tool to find your technical debt, which is that what is the delta with the state which you want to have and where you are. For that, you have got tools like Sonar, Square, and all the tools available. I'll be talking about the tool Sonar while towards the other part of the presentation. Then you should be thinking about what are the different ways then you can find your static and dynamic code analysis, and then how you can fix it. So there are tools like Resharper, Visual Studio, and then there are different patterns to work for the dynamic part. In terms of tools and trainings, this is where so tools like FXCorp, StyleCorp, GenRam, and these other tools are available, which can actually help you to analyze and measure code. And lastly, you would have seen that there are things like best practices. There are Microsoft best practices for CHash, Java best practices from Oracle. Then there are multi-threading best practices. So all those things, you should think that this is a part of the equipment or the tool set which has been provided, and then you should look at that under this bucket. So the only thing which this bucket is trying to do for you is enabling you to have those equipments. Right now, it doesn't tell you how to use it. Yeah. So we will see how to use these things. And most of these tools are available freely, so there is no cost available. It's just that you have to understand how to use it. As I was talking about that there are tools for static code analysis, this slide actually tells you that how to do a dynamic code analysis. So dynamic code analysis is that where so you have certain code written and which your tools cannot catch, and this is something which a human intervention is required. So if a human intervention is required, then also there are methods and tools available which can actually make your life easier. For example, this kind of cheat sheet which I have created here, it is very useful because what I have tried to do here is that I have tried to identify the different patterns of a smelling code. Smelling code is basically code which is not written up to quality. Yeah. So that spelling code is actually divided into 5 different buckets here: object-oriented abusers, and couplers, bloaters, and dispensables. I'll take just one example. For example, if you are dealing with the bloaters, suppose someone starts writing long methods, which is a cause of a problem, because if you are writing too long methods, it is difficult to maintain, manage, and test. Now, this actually shows that there is a way to solve it. Yeah, the way to solve is that if you are having a long method, you actually solve it by a process called extract method. And similarly for all the 20 different patterns which you have identified. All these patterns are easily available on net and all, but just that what you need to understand is that you have to think in this direction. And then you have to educate your people and educate your team to follow certain things like this. Okay, so we have talked about the quality coding framework, and we discussed about the first element of that, which is the code quality, which actually enables you to have a different tools or equipment to solve it. However, it doesn't tell you anyways how to use those things, and this is where we actually start using it. On continuing our example of the where we from the kid who wants to become a cricketer, Sanjay, he actually now he has enrolled to academy. He has now tools like bat, ball, and all those things. But now he has to start learning, right? So he starts practicing, and the thing which actually he does is that now he needs to have a continuous feedback about how he's practicing and how he's improving. This is manual in this case because someone has to tell him that, okay, you are playing this shot well or not well or something. In our software world, we also need something similar, wherein we have to have a continuous feedback mechanism. Whatever we are writing, we should have a definite feedback about what exactly is going through, and then what exactly it means. This actually is obtained, and this actually is achieved by something called continuous delivery framework. This is an amalgamation of things like continuous integration, and also about build automation and deployment automation. So I'll be talking about this. So if you see here, this actually introduces you to the concept of continuous delivery framework or the continuous integration framework. And there are certain things which should be done here. In terms of code lifecycle, where you are right now is that you have you have started writing code, and whenever a developer checks something or he actually commits something, then he should get a feedback whether that code is in what state, right? So a framework like this will help you to set up your project or set up your solution or set up your infrastructure for writing code. Then it will help you to enable and for continuous integration, which enables you to have a feedback for your builds, feedback for your integration, feedback for your integration cycles. You can enforce coding standards which you have tried to gather from the quality coding aspect, and then you can enforce whatever you define or whatever you have got from market. Then you move to the integrated quality enforcement area, wherein what you can do is that you can check your unit testing coverage, your integration testing, and sniff testing coverage areas. Fifth thing, if you see here, is about quality metrics. And what actually this means is that you can have a dashboard which can tell you and show you that what exactly is the level of your code, which is which has any violations, what are the different issues. So in these tools like Sonar, Squale, FXCog, and all those tools are useful. And lastly, if you are able to deliver or write good code, then the other aspect is that the delivery should be seamless, and the delivery of code should be easy and prompt. So for that, there are products and there are features available which can help you to quickly get those things. Yeah. So overall, if you see here, how actually this fits into the whole perspective is that you have tried to gather the equipments under the quality coding umbrella. Then you have tried to have a continuous integration or the feedback mechanism by using this CDR framework, certain tools like frameworks like TeamCity, Hudson, Jenkins. These are all are available, which can be used for these purposes. In terms of benefit, if you see, it actually, there are several, and I have just tried to list a few of them. It actually helps you to reduce your initial setup effort for the solution of the project, which you have to do. It enforces, very important thing is enforcing quality standards, and in general, this actually has it encourages a more predictable code quality. So here, what I'm trying to do here is that I will try to show you an example of a tool called Sonar, and this tool will actually tell you that how this continuous integration and the how code analysis thing will actually can help you. This tool is freely available, and it can be used for Java and .NET projects. And as far as I'm aware, it has got plugins for other coding languages as well. So it is up to you to how to basically adopt it. It can use plugins like FXCorp, StyleCorp, PMD, check style, find bugs for static code analysis. It has integrations for unit test frameworks like JUnit, NUnit, Mockito, Amokio, and other stuff. And also, it can integrate with NCover and OpenCover so that you can have your test coverage results. Now, in the next slides, I will try to show you some visual graphics of this tool Sonar, so that you can appreciate that how exactly you are able to measure and understand your results of the code. For example, this is a standard dashboard which you see from Sonar, and what it does is here is, if you see, that it will tell you what are the lines of code in which you have on your project. Then it can show you that how many classes you have, what are the levels of comments you have, what are the violations which exist in your code. And it even goes to the level of telling you that what are the blockers, critical, major, minor, and all those different issues. Important thing here is also to understand that you can even go to the level of the code itself and see that which actually code is having a problem. It also tells you things like having a good, whatever code coverage you are having. So in this case, whatever you see is around 56.7% code coverage. Yeah. This is another second level of dashboard, wherein what you have done is that you have tried to click on, say for example, getting the major issues which exist in a code, and it shows you, it actually points to the exact line which has an issue. So in this way, so you don't need any definitive code review process for it. You just deploy this tool, and then it will tell you the exact thing which has actually happened here. Now this is a view which from Sonar, and this is pretty useful for not only developers but project managers and people high up in the hierarchy. This shows you the every image here actually shows a different project. So this is a view of the whole ecosystem of an organization, which shows that few of the projects in the organization are amber and the other ones are green. And then you can click and then go inside and then you check the health of each and every project. So this is a extremely useful health check or a heat map mechanism for the whole organization, and it's widely used for the same purpose. Now this is another very interesting thing, wherein you can actually check that what was the state of the code on a certain time scale. For example, if you see here, on 30th of July, you can go and check that how many lines of code you had, what was the complexity, what were the rules, compliance, and coverage. And then you keep moving in the cycle, and then you can have that data or a history ready at your will. And this is excellent to understand that how you have progressed from one state to the other state. So until now, we have covered two important aspects of code quality framework. So the first framework is about having the equipment, which is the quality coding. The second is about the continuous feedback mechanism, which is the CDF. We talked about things like tools like Sonar. The third and the very important aspect here is how should we approach code? How should we start writing good code? What is a way that we follow that it can result into good code coverage as well as good quality code? So my recommendation here, or what we have followed in Sapien, and then what we recommend is that one great way of doing that is following test-driven development. So I'll be talking about test-driven development in the next slide, but I'll also try to again hook this story to the story which we had, wherein the kid who was a developer who wanted to basically become a good cricketer. Yeah. So the kid actually had equipment. He is now able to get feedback, but now he wants to understand what are the best shot, how he should play, and he actually needs some coaching. So he needs a coach basically. He assigns, so there is a coach assigned to him, and then he starts learning the good way of doing it. Similarly, in our world, this actually role is played by a test-driven development. So test-driven development is a shift from our conventional mindset, wherein you first write code, and then you write a test, and then you write a test to basically test it. In this approach, what we do is that we first write a test, then we write a code, and then we actually refactor that, and then we keep doing it until a point that we can't think of any more tests. So few people can argue that what exactly is this, right? So what is this way of doing it? How can I write test and then I can write code, and then why should I do it? The reason for this paradigm shift of mindset is that more or less a lot of us have moved to an agile way of development, and that means that you have to start working in sprints or iterations. That could be as low as 3 weeks or 4 weeks. And what happens is that whenever, so if you are developing a code for a 3-week sprint, then you will be given functional use cases, and based upon that use cases you have to develop code. The problem with the conventional way of coding is that if you're just trying to write code first and then you write test, you actually either write something which is not required, or you may write something which is required, but then it is more than required. So there is it is a difficult thing to basically maintain that sanity that you just write what is required. So that is why what you do is that you just read your functional test case, and based upon that domain understanding, you start write a code or a test case which says that what exactly are you trying to do. The moment you do that, you are actually trying to have your head fixed to the domain, and then you actually write the correct and the required code. If you see on the screen, I have mentioned that core of test-driven development is you write a test case, then you think about what you have to write in terms of code. You make sure that you think about, and then you make sure that it actually scales first, so that there is no chances of that you have written something which is ambiguous or which would have dual meaning. By dual meaning, I mean to say is that maybe that you have written a code which actually passes not being the correct scenario. So you don't, in order to move from that point, you have to make sure that your test first fails. Then you make sure that your test passes, and then the other important thing to notice will be that you have to think about refactoring your code. You can never write, as a developer, you will never be able to write a code which is up to production standard at the first go. Do not worry about it. Write a functional code. However, even if it's spelling, don't worry about it. Write something, and then you keep refactoring about it. And then tools like static tools like FXCOP, CellCOP will help you, and then the dynamic process which I defined about earlier, the refactoring patterns will also help you. So this is the way you to approach it. The overall mindset of TDD is all code is guilty until proven that it is innocent, which means that do not assume that this particular code I've written that it will work until and unless there's a test which actually tests it and it should pass. There are several benefits which are actually available from it. TDD in itself is a very vast topic, and probably next sessions probably we can speak about it also. But what I want everyone to be, whoever is available here and listening to it, to think about that. If you want to follow an agile methodology, if you want to basically write covered code, then you should think about following TDD. It actually improves your quality. Very important thing to note here would be that it improves your code design, because you are now thinking about your domain or the functional aspect. Then you actually create a design which is very appropriate and close to what is required of the software, and it often results into high test coverage, because you are first writing code and then code. So more or less what my experience has been that it is about 100% code coverage if you follow TDD. So TDD concept is very good, is very useful and very powerful, but there is a learning curve, and then there is a mindset shift which you can do by some trainings and all. But how do you actually do it? Because if you have to write a test which interacts with external systems, it is not so easy to do unit testing. So in order to facilitate that, what test-driven development in terms of tools have is that it actually extends several tools and concepts like mocking and stubbing. So what mocking and stubbing does is that if you are able to mock, then what it does is that it will quickly create and consume stubs and mocks. What it means is that suppose you have to write a test case for a certain code, you don't have to worry about the different setups which you have to do, different conditions which you have to set up before you can do that unit test. You just have to worry about what exactly line of code you have to test, and then all the other things can be mocked or stubbed. These mocked or stubbed are nothing but fake objects and fake objects which can actually act and help you just to simulate that environment. And so there are different tools available for Java and .NET. For example, in the Microsoft world, MOQ, for example, is the pretty neat and simple tool to start with. Then there are other tools like Microsoft Moles, Rhinomox is there, and latest is the Microsoft Fake, which is available from the Visual Studio 2012. And so this is one of the most excellent tools which actually I've understood, because it is not only able to do the mocks and stuff about the code you are writing, it can even mock the external libraries which you can test. So this is a sort of a holistic framework which can even test your legacy code. Yep. So this is about the test-driven development. So until now we have covered the third important aspect of the code quality. I'll again reiterate. The first one was about the quality coding or the equipments about coding. Second was about the continuous feedback or the CDA framework, and third was about the test-driven development. Yeah. Going back to our example where the young cricketer Sanjay, who actually wants to getting back to the story, so he actually went to a stadium. He starts learning that. He has now a coach also to guide him. But what he feels now is that he has been practicing for say 6 months. He wants to talk to a fellow batsman. He wants to discuss that how batting goes about. He wants to know that what are his ways of understanding things. So in the programming world, this the similar thing about this is that you have to think about a pair, a person who is sitting next to you is also a developer, and then you actually start working on the same thing together. This is very interesting concept, and this has been excellently pretty useful about developing a good and quality code. Yeah. So I'll just quickly, very quickly try to explain you that what exactly this concept is, and then how it actually helps you in terms of doing and writing solid code. Yeah. So let's assume a scenario that there is a setup where the team will ask a developer to develop a story about our user authentication module. So he starts developing, but what will happen in terms of pair programming is that two developers will sit together. One will be called a driver, who will actually be only working more actively, and then he will be writing and typing, and then explains the actions taken. And then there will be the other person who will be acting as a navigator. The role of navigator will be that he will be more tactical. He will be asking strategic questions. He will be questioning or discussing the design aspects, the functional aspects, the NFR aspects. And he participates in brainstorming and planning. So what will happen is that these two people they will sit together, and they will work on the same functionality, and they will try to develop it. Needless to say that the way the knowledge sharing actually happens here is very fast, and that we will see in the next slide, wherein we will see that what exactly are the factors which help a pair programming framework to work. The first thing is that is about the peer pressure. Yeah. How often than not we see that, say for example, if you are assigned a story, you start working on it, but then you really get digress, and then you open some social media sites, and then you start going there, and then you maybe start reading about some design document or design aspect. But what it does is that it actually deviates you from the core job of actually creating what you have to do. While you are working as a pair, how it helps is that you actually work together, and the peer pressure that somebody is sitting next to you, that you have to concentrate. What happens is that you start focusing on the core thing, and what it helps is that it actually helps you to deliver things fast, tidy, clean, and with quality. Then there are other things like it actually increases peer reviews. You don't have to wait for some external review or tool to do it. You have a person sitting next to you who can help you to do the review, and then review design or code. It helps in peer learning, because as we understand, each one of us brings different skill or different perspective to table. Maybe that a person who doesn't understand that language or concept very well, but what he can bring to table is that he can bring a different perspective, and that's how we actually learn together. So this slide actually talks about the benefits of pair programming, and then also that there has been some criticism also for the pair programming, and a lot of people in this group would actually agree with me that there are definite things which actually tell that pair programming is not pretty useful. Things like people say that it decreases productivity. Some people say that coding is in general a very isolation act, so it should not be done in pair. Few people have issues like it actually has egos and disagreements, so it is not so useful. So there are a whole lot of apprehensions about doing pair programming. But what our experience has been, or what the industry experience has been, and there has been several research as well as practices at different industries, what it shows is that while you are trying to pair, it tends to decrease your productivity by say from 10 to 15%. However, it actually decreases the coding issues or bugs by more than 50%. So if you are in that case, what is happening is that you are able to avoid a lot of defects which can happen at a later stage. And we know that any issue or a bug which happens at a production stage takes more than say 10 times of effort, while if it was caught at the developing stage. So these areas it actually makes very helpful. But 2 or 3 things which should be kept in mind is that if you use your understanding or prerogative to understand whether you should be doing pair programming or not. In case functionality is complex, in case the functionality is domain heavy, please make sure that you actually get this story in your pair programming mode. But if it is a simplistic story wherein you have to do something which already has been done several times, you have a code base ready for that, you have a fair understanding, then you should not worry about pair programming. You should be directly delivering it. Yeah. However, if you hook back to our quality coding framework, pair programming helps with that in terms of higher quality and in terms of imparting knowledge also, right? So at all levels, these pair can actually coach each other that whether they have uh, whatever tools or skill sets they know, and then they actually talk about it. Yeah. So now we come to the last aspect of code quality, and this is the test coverage. So if you go back to our story of the young cricketer Sanjay, so he actually enrolled to a sporting academy. He started practicing. He has a way to get a continuous feedback. He also got a coach, which actually helps him to know what are the shots and all those things. Then he actually also got a fellow batsman who can discuss with him. So these are the things which he has already got. But will it make sure that he will, he will become a good cricketer? The thing which is pending is he should know what has he covered until now, what is left. For example, suppose there are 10 different shots available which a batsman should be playing, and he has only practiced or mastered one. Then he should know that there are 9 more available to go to, right? And that's how you will start actually growing in that. Similarly, in our coding world, that is being done by code coverage or test coverage. So if you have a unit test coverage which says that whatever lines of code you have written, they are covered by unit test, you can measure that coverage, and then you can check that what is your level of confidence or what already is being covered. In case you have a good percentage like more than 80 or 90%, what will it will ensure is that there will be so the turnaround time for code changes will be very, very high, because you don't have to worry about what change you have done and then how exactly it can have an impact on the overall solution. If you see this screen, I have tried to list here scenarios or a snapshot from the dashboard of Sonar. It can also come from tool like OpenCover or NCover, wherein you can go and measure your code coverage. So in this example, if you see, it is 70% odd coverage, which means that he has to make sure that other 30% of the code has to be covered as well. So code coverage in general results in a better overall maintenance of code, and then there are different tools of doing it. Yeah. This actually ends our all the different 5 offerings which we had for the quality coding, and then how exactly they can help. The important thing to understand or appreciate here is that these tools are not milestones. This is a journey. This is every day. So if you follow these things, you will basically get hooked to a quality mindset and a framework, and this will make sure that you have to deliver things in quality. For example, in case that you actually write a code and then you run your Sonar report, it tells you that you have got say 500 violations, blocker violations, then you have to refactor it and fix it. So this setup will make sure that you enter a setup which will make sure that quality is the ultimate aim. Yeah. So this ends our second aspect, which is about the 5 elements which we have talked about, and now we move to the third and the very important aspect, that as an individual you might be knowing that what a good code is and how it has to be followed, but how do we make sure that it actually gets socialized or adopted in your organization or in your team? Yeah. So what we did was that we created a suitability or a maturity check. And what this check does is that it actually tries to check the current state of your code and where you are, and then it tries to tell you that it tries to give a feedback that what elements or what parts of the framework you should be following and what you should not be following. Assuming that if it comes out that you have to follow the quality coding framework which you talked about, then the second aspect will be that now your team has to get enabled in that, so that everyone in your team should learn the concepts of quality coding, learn concepts of test-driven development, learn concepts of how to do good test coverage, then concepts of what continuous integration or continuous delivery framework is. Then you can come to a point wherein you say that now I will start adopting that in my team, which means that you will start taking baby steps and then in working on certain things, and then you have to measure how you are progressing. Yeah. What we did, and then what we found useful was that we set up a small quality coding framework team with the experts, and then different projects in our ecosystem used to work in tandem and together, and then they actually divide roles and responsibilities in following these steps which I've mentioned. This is one example which is about I was talking about a suitability of matrix or check, right? So this is just one example of it. So if you see here, what this does is that there is a continuous delivery framework, which is the CI framework, and it has got questions like, does your project already have a standard solution or a build process? Does your project already have a continuous integration framework or not? So there are several questions which we have evolved over time, and you answer these questions based upon your questions and understanding. We are able to make out whether you need this thing or not. Yeah. Similarly, for all the other four different elements, there are questions which are supported. Based upon this, we are able to measure whether you need something of this sort or not. So the message which I am trying to convey here is, in your organization or your team, you should not blindly go and follow any of the framework or tool unless and until there is a definitive need. One important thing would be that, for example, your code or your project is already into production, and the only thing which your team right now is doing is bug fixing, which is also happening at not so regular intervals. So if you want to think about deploying test-driven development, or you want to use things like CDF, it might not be useful. It might not make sense for you at that stage, right? So take a well-informed decision. Take a and understand that whether it was required or not. Yeah. So we talked about a suitability metrics. We talked about that how exactly you can check whether you need something of this sort or not. So here, what I'm trying to show is that, and what we did here in Sapient was we actually tried to divide these 5 elements which I talked about into different sub-elements. And I also tried to give weightages to this, right? So these weightages actually represent that what is the importance of that particular sub-element or a task within the whole framework. For example, in terms of quality, in terms of continuous delivery framework, if you do a continuous integration setup, you get 10% marks for it. Or for example, in test coverage, if you reach to a point wherein you have got 70% plus coverage, you reach to a point where you get 10% of the weightage. So all these things actually make the quality aspect of perspective, which is very, very field based, to a very measurable measure based, right? Now what this is trying to do is that you can see that how you are moving, what aspects are tied to what, and then how you can make progress in that direction. Yeah. We also try to come up with a self-rating model, right? And what this rating model tells is that in order to make your team competitive and then feel about quality and feel about features, why was you actually start rating yourself. If you understand here in this slide, as I told, you can give different weightages of marks to different sub-elements, and assume that if you reach to a point where you score 30%, then you can rate yourself as a 1-star team. If you move to 50%, then you can be a 2-star team, and henceforth, if you reach to 100%, then you are a 5-star team. And imagine a scenario wherein all the projects have a star rating, then they will be actually able to work more competitively, and the environment of quality and environment of that mindset will prevail. And this is as we have experienced, this is something which actually helps a lot to drive these things forward. Yeah. So with this, I will try to summarize that what we have discussed, and then what exactly we have discussed until now. So I started with discussing what quality mindset is, and then I tried to basically talk about different perspectives of quality, then I also discussed about the challenges which exist in understanding quality. Then I talked about the quality coding or quality development framework which we have developed, and then what are the different elements in that. I talked about test-driven development. I talked about continuous delivery framework. I talked about practicing pair programming. I talked about the coding equipments for the coding, quality coding, and then I talked about the test coverage part. And then last thing which I talked about was the adoption strategy, how you should socialize this thing within your organization, how you should try to help this for adoption, and then in overall try to measure your current state by using the suitability metrics, have these steps of doneness where you actually assign your finish to the different things, and lastly you try and have a self-rating mechanism or a matrix which makes your environment competitive, and then you are able to move in a certain direction. I want to end this with saying that I am a quality developer, right? So you have to start feeling and you have to start living this feature that words like developer pride, or words like that I actually live quality, and then I am a solid developer. So these terms should be socialized, and these should be felt, and you should be really proud of it. And please try to imbibe these different elements, and so that actually overall you are able to improve on quality. With this, I think so these are the different references which actually used for slides here, and with this I actually end this, and then I'll be actually taking up questions. Moni, can you please help me with that?
Well, thanks for the insightful presentation, Sachin. I've assigned you a few questions. I hope you can see them now.
Yeah, I can.
You can start with the questions and answers now.
Yeah. Okay, cool. Okay, so the first question which has come from Deepak is that pair programming is a great way of learning, but how long should we follow this practice? Is it 5 days or 10 days or what? Okay, great question, Deepak. I like your question. So pair programming, you should not only see this pair programming as a learning experience. This is more about delivering, delivery aspect as well. For example, and then also you should not time box it, right? So it is not about if you follow it for 7 days, you actually have learned this, and then you leave it. You should make sure that it becomes a part of your daily sprint or life cycle, right? Suppose there is a complex story, you pair with someone whom you think that can add value. Try to work on the design, try to work on the implementation level details, try to break the complex parts, develop together, and until the point where you see that now it is fairly easy to code, you should pair, and then you should also try and help the other people in the same way, and then it should be continuous exercise, and then it should be always done. So I believe that is a way to actually take it forward. Hope that this helps you, Deepak. Yeah. Then I'll take another question which has come from Eljo. He said that do we have a Sonar plugin for Eclipse for Java? Yeah, so I think it pretty easily gets integrated, right? So with Eclipse IDE, so I don't think that there is any problem with that, right? So it's pretty straightforward. Then I have another question which has come from Nidhi Setia. Very interesting question, very good question here, which says that what is the difference between TDD and mock tools? So these two are keywords actually. So test-driven development, for example, is a mindset where you actually start doing test-first approach, and so you can do test-first approach by 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 following unit testing, as well as you can use unit testing using mocking tools, right? So if you are if you just understand that and for example, mocking tool is also a part of TDD tool, right? So it is basically that uh, you will understand that it's a subset of it, right? For example, NUnit or MS test or these things are also TDD tools, whereas mocking tools like MOQ, Microsoft Fix are also TDD tools. The only difference here is that NUnits are basically functional tests, so it will help you in testing functional and state-based tests also. However, these mocking tools more often than not are trying to test you in terms of isolation testing, right, or interaction-based testing. Yeah. So hope this answers your question, Nidhi. So next question is from Avinash. A very good question here. So he says that I am a new developer. So does this quality coding applies to web development also? Yes, it does apply to web development, Avinash, as well as it applies to any kind of code you do. For example, I talked about following quality coding, right? So in terms of web developer, suppose you are a Microsoft developer, and then you have to code either in ASP.NET or MVC or MVC3 or Silverlight, whatever it is. You go and find the exact best practices for that. Then you start following the CI route, which is basically you should have a continuous integration route so that your build is build gives you the solution. Then you actually follow TDD, because if you follow TDD, it will help you to basically have good coverage and and things. And you also should plan for good code coverage or good test coverage, so that your code doesn't break and then it has good coverage. So it applies for you in any aspect. It is not only for web. Even if you are, say, for example, a PHP developer, it applies to you there also. Yeah. Hope this helps, Deepak. Avinash. Okay. So there is a question from Mini. What is when it is a pair programming, won't it take more time than the estimated one? I would say this is the question of the day actually. And Mini, so I understand where you're coming from. So it can take more time for sure. That, and as I said while I was taking the presentation, that it typically, so the research or the estimates or empirically it has been seen that 5 to 10% of the delta comes. But how actually it gets covered is that you produce a better code which has 50% lesser defects than what it could have been. So if you consider that the defect which comes at a later stage, at integration or the production cycle, then you are actually saving a lot of time. Yeah. And then things like peer pressure, wherein you are able to concentrate more and then deliver faster, that also helps to basically reduce the cycle. So yeah. So I think that helps me. Then there is another question from Subramaniam, which says that what type of projects can we follow while we are doing a dynamic code analysis? Yeah. Yeah, so I think this is for all kind of projects, right, Subramaniam? So basically, so I mean, what I mean by static and dynamic here is something which any code analysis which can be done by a tool automatically is a static analysis. And if static analysis is not there, then you have to actually manually do something. And while you are trying to do manually, you have to actually try to create under different frameworks for that, right? So you should create something of that sort. For example, I actually showed you this slide where actually I had the frameworks for that. For dynamic analysis, it is actually valid for every scenario. Then there is a question which has come from Vijay Kumar. He says that sometimes best practices provided by concerned technology vendor is overridden by the industry specific. Is it true in the perspective of global IT market? Okay, very good question, Vijay. So, I mean, it is true at places and at times. It depends upon it depends upon that where exactly you're working. But if you see more or less, there are these standards are pretty much same, right? So I mean, like for example, I haven't seen different levels of coding standards or best practices at different levels. So even if it is there, as a developer or as a team, what you should do is that you should have your own version of standards, and whatever standards have been pushed to you as a company, you should try and discuss with them that these are our understanding of the standards, and please see that these extra features are there within our perspective, and they should be added as well. And my experience is that more often than not it has been added in that, so it should help you. Okay, then there is a question from Prasanna, which he says that can we have one .NET developer and one DB developer as a pair-in-pair programming? Very good question here. And okay, so answer lies in the common sense here, right? So if you are a .NET developer who is working on and then the story which you are developing involves a native SQL code, which actually tries to do something which is performance heavy in terms of DB, then you should definitely work together, and here you both will be able to help each other, right? So the DB developer will be able to help you with the optimized query, and the .NET developer will be able to write the code which is adjoining that. So in that case it can be done, but in general this is this kind of setup is very specific. Yeah. Okay. Then there is another question from Shashidhar. What he says that when you have a legacy application where your test coverage is very low, how will you go about TDD? Okay, so if you have legacy code and then if you have to go about TDDs, and then the way to go about that is that there is a now framework available from Microsoft, at least in the Microsoft world. It's called Microsoft Fix. What it does is that it is able to generate mocks even for the third party or the vendor libraries, and it is pretty easy as just creating an object of that particular code, and then it can actually try and help you. And actually it is called shims there, right? So Microsoft shims, shims are there, so which is fakes and shims, so this actually helps. And my experience, so I have done something similar for a legacy application, and then using this Microsoft Fix was pretty easy because it actually was quite easy and quite fast to do it. But in general, if there is a legacy code, then it is a bit difficult, but you have to use these tools, right? Then there is a question from Shiva Shankar. And what he says is that does quality coding be applied on a larger perspective, say at a program management level? Very nice, very good question, right? So while we were trying to create this quality coding framework, so this actually is just one part of it, which is the coding part of it. It can be applied to program management, it can be applied to IT, it can be applied to sales, it can be applied to marketing. The only thing which you have to do is you have to identify the elements which are appropriate for you. For example, if it is program management, then I would say that program management tools will be the equipment for you, wherein you will have to learn tools like any status tracking tool, or any tool wherein you tools which like Microsoft calendars, I mean different tools which are available for PMs. And then what you have to do is that you have to see that whether you actually understand those things or not, right? So you can find your own elements of that, and that's how you can actually implement it. Yeah. Then I have another question which is from Suhash, and he says that whether there is any C plugin available for Sonar. Yes, so good news for you, Suhash, that there is a C plugin available for Sonar, and it's very easily available and hooked up. So we have tried that, yeah, and we have tried that, and it works pretty fine. Then there is one question from Dheeraj. He says that any tips and best practices based on your experience that would take normal development to solid development. Yeah. Okay. So the first thing Dheeraj, which you have to do is to understand that quality has to be managed or maintained. and by asking this question, you actually are trying to signify that. So once you do that, what you do is that you actually start using tools like Sonar and FXCOM and StyleCop. You try to run these tools and analyze your code. It will tell you the current state of your code. For example, it can tell you like how many violations you have, what are the lines of code, what is the complexity, what is the cohesion level, what is the coupling level of your code. Once you have that, it will be very easy because it will tell you a path what to fix. So solid code can only be written once you have a current snapshot. So you try and do that, and I would say that installing Sonar or those things is pretty easy. So within 3 or 4 hours time, you will be able to deploy it, and then you can have a complete analysis report in say a day, which will make learning path or development path for you. Yeah. Yeah, so I think I just have a couple of more minutes, so I can take maybe one or two last questions. Okay, so there is a question from Manoj. He says that in agile framework, will weightage will work for or percentage level will work. Okay, so I think probably I don't understand this question too well. So I will move to another question, which is come from Vipul. He says that I understand the importance of pair programming, but in organization with limited resources, is it good practice to do pair programming? If not, can you suggest any alternate? Vipul, so it is like this, right? So whatever, even if it is a small organization, what is expected is that you have to you have to develop good code, and you have to develop code which actually suffices to quality standards and to customer requirements. And I would say that in smaller organization it is much more important because you have got limited projects or limited projects, and then these projects have to be delivered to the best of the quality, right? So it's more about the mindset thing, right? If your setup actually appreciates something like this, they will allow you. And my advice to you would be that just do try and do this for a week or 10 days with any developer, and then see how the experience goes. If that is not working out, then you can think of alternates. Otherwise, our experience says that it has worked for most of the people. Yeah. I think probably with this, I think probably I'll end. Thank you very much, guys, for asking these questions, and then being with me for so long. What I will wish is that everyone should be able to take at least some takeaways, and then they should explore more about these different elements and try and build a better and more productive and quality world. Thank you very much.
Well, thanks Mr. Sachin for the insightful presentation. I'm really thankful to you for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for the support in making this webinar a success. The recording of this session would be available on techgeek.com by tomorrow. Thank you all. Have a great evening.